Hello there, your buddy Phil. We got a question from one of our students, Kylie, about the Monte Carlo simulation. So we're going to take a look at this topic in the PMBOK guide under simulation and what if scenario analysis. I'll just say that for your PMP exam, make sure you understand what is in the PMBOK guide at the level it is, and that should be sufficient for your exam. Here's a question. You're conducting a schedule network analysis using the schedule to compute the different scenarios, such as delaying a major component delivery, extending specific engineering durations, or introducing external factors, such as a strike or a change in the permit process. What does this best describe? Now, if you take a look at the question through the process of elimination, you can find the correct answer. So the first one says, using the schedule to compute the different scenarios, that right there is likely to not be decision tree analysis because it usually has to do with cost or financial related decisions. Now, if you're going to make a schedule decision, this will not be the best tool to use. So it will not be option D. We could cross that out. The next one says, what if scenario analysis? Now, this is not a bad option. What if scenario analysis is pretty much tweaking the schedule, seeing the effect of that tweak in the long run. You're not changing the schedule finally, you're just doing a what if type of experiment. So using the schedule to compute different scenarios, if I delay this component delivery, what happens to the rest of the schedule is actually not a bad option. So let's leave what if scenario analysis. Let's go to quantitative risk analysis. Well, again, from the PMBOK guide, quantitative risk analysis involves finding out the quantitative effect aggregated for risks on the project. That does not sound like what we're doing here. Last but not least, it has a Monte Carlo simulation. Now, to get this question right, you need to know the difference between a Monte Carlo and a what if scenario analysis. So what I'm going to do is very quickly search for these keywords. Delaying a major component. And what happens when I punch that in? It takes me straight to 6.5.2.4. It's a what if scenario analysis. If I change the schedule here, what happens downstream on the project? And that's why the answer is definitely C and not A. A is more intricate and it would require software to run, not just a schedule. So the answer to that question, my friends, is what if scenario analysis. And I would like you to read the full page paragraph there that says, what if scenario analysis on page 213 is the process of evaluating scenarios in order to predict the effect, positive or negative, on project objectives. This is an analysis of the question, what if the situation represented by scenario X happens? A scheduled network analysis is performed using the schedule to compute the different scenarios, such as what happens if we delay this component? What happens if we extend specific engineering durations? Does it push out the end date in the schedule? Your schedule should be built as a cohesive moving train, if you will, where one carriage is pulled by the other. In other words, it's linked. So if you change one aspect of the schedule, it should reflect in every other aspect happening in the future. And that's why the answer is what if scenario analysis. Moving along, what if scenario analysis is the process of evaluating scenarios, just like I said. What if the situation represented by X happens? Now you understand what if scenario analysis. Let's move on to another question. Your sponsor has asked you to utilize a computerized mathematical technique that allows people to account for risk in quantitative analysis and decision making. The technique is used by professionals in such widely disparate fields such as finance, project management, energy, manufacturing, engineering, research and development, insurance, oil and gas, and transportation, and the environment. What does this best describe? So again, using the process of elimination because of a set of keywords here, namely computerized mathematical technique. There is only one that fits that best. And it's not decision tree analysis. That doesn't have to be computerized. It's not what if simulation, because as you saw in the last question, we could very well use a mere schedule to do that without any mathematical computerization. And the next one, quantitative risk analysis. We already know that this is finding out the aggregate effect of risks on the project. So the answer has to be Monte Carlo simulation. If you take a look at the PMP guide, you do a search for mathematical technique, it will come up with something probably close to this. The keyword is mathematical. Mathematical techniques. This is what we use when we're doing a Monte Carlo. Now, you might find the word mathematical in a number of other places, but I want to read for you in the PMP guide immediately after what if scenario analysis. It reads, simulation models the combined effect of individual project risks and other sources of uncertainty to evaluate their potential impact, that is, on achieving project objectives. The most common simulation technique is Monte Carlo analysis, in which risks and other sources of uncertainty are used to calculate possible schedule outcomes for the total project. Simulation involves calculating multiple work package durations. So what does that mean? You are calculating multiple durations, possibilities for work packages with different sets of activity assumptions. Remember, your work package contains many different activities. And if you're taking a look at each of these activities with different sets of assumptions, constraints, risks, issues, you are going to come up with a number of potential values for those work packages. Now imagine doing that several times over. When you do that several times over and you combine that with a sensible and solid mathematical model, you could use a Monte Carlo simulation to predict the effect on the project. And that's exactly what this is saying. It says 11.4.2.4 shows a probability distribution for a project. Now let's go to 11.4.2.4 because I want to put a face to the name and I want you to see what exactly they're talking about in 11.4.2.4. So let's try and get that open in the PMP guide. 11.4.2.4. And when you get to 11.4.2.4, what you are going to see is figure 11-13. Let's go to 11-13, and this is it right here. And if we read what the PMP guide says in chapter 6, where it was referenced, you can see it shows a probability distribution for a project with a probability of achieving a certain date, that is, a project finish date. In this example, there's a 10% probability that the project will finish on or before May 13th. It says, while there's a 90% probability of completing the project by May 28th. Now, I know they have mentioned 11424, but really what they are trying to get us to see is 6-18. So that is not the exact image that we should be showing right now. We should be showing another image from chapter 6, this one right here. So if you take a look at what they're saying here, there's a 10% probability that the project will finish on or before the target date of May 13th. When you take a look at the image, the 10% probability they're trying to show you falls into this domain here. 10% probability that you will get that date. There's a much higher likelihood that it's going to be after the 13th. As you can see, there's an 80% probability that it's going to be after the 13th of May, somewhere between the 25th and maybe 26th, 27th, 28th. So it says there's a 90% probability of completing the project by May 28th, and that's including this 10% probability. The likelihood of this happening is 90%. So what this Monte Carlo is doing for you is really just showing you that based on the data, based on the statistics, based on the model, you are likely to complete this project somewhere in this time frame. Okay, the likelihood of you finishing by the 13th is very low. It's only 10%. So it would make sense, instead of fixing the date here to finish the project, why not go with reality? So what can we say about the Monte Carlo based on what we've seen? It helps us understand the possibility, the probability of us achieving certain cost or schedule objectives. Now, I don't want you to be concerned too much with how this data is gathered, because that is outside of your PMP exam prep. If I were you, I would rather focus on understanding the concept. One, it's a mathematical method using a computerized algorithm to help us better understand possibilities on the project. That's how I would approach this for my PMP exam. Now, if you want to know a lot more about how the Monte Carlo works outside of the PMP exam, I would advise you to go to the website palisade.com, PALISADE.com. They have a Monte Carlo simulation software tool. It's an add-on that you can use with MS Project and even Excel. Now, you can see the probability distributions on the right. These usually cause a lot of horror in the minds of people taking the exam because they immediately think the PMI will test them on this. It is very unlikely that you will get a lot of questions that revolve around this, if any at all, but nonetheless, this is common sense. So let's read. The Monte Carlo simulation performs risk analysis by building models of possible results by substituting a range of values, a probability distribution for any factor that has inherent uncertainty. It then calculates results over and over, each time using a different set of random values. Remember, I talked about random values and possible constraints and different parameters for work packages. Well, that's where this comes in. So this is what you need to grasp and understand for the exam. It's a mathematical model. We're using several permutations and combinations. And once we punch those into the computerized system, the Monte Carlo, depending on the number of uncertainties and the ranges specified for them, the Monte Carlo simulation could involve several thousands of recalculations before it is complete. The Monte Carlo simulation produces distributions of possible outcome values by using probability distributions, which you see here. We have different distributions. I don't want to go into every single one, but there are a few you should be familiar with. The triangular distribution, very obvious. You can see the shape there. We have the PERT, which is based on the PERT formula. You know, the P plus 4M plus O divided by 6, and many more here. Okay. So my concern is for you to understand the concept. So by using probability distributions, variables can have different possibilities of different outcomes occurring. Probability distributions are a much more realistic way of describing uncertainty in variables of a risk analysis. We have a number of these distributions. I don't want to go into all of them, but we have the normal or bell curve, log normal, uniform, triangular PERT, and they have extensive definitions behind them, which I don't care to go into. Here is a closer look at some of these from our friends at Palisade. So all the way from the normal or bell curve, which defines the mean pretty much, or we have the log normal where the values are positively skewed. It's used to represent values that don't go below 0, but have unlimited positive potential. Many different types. And there's really no need for me to go into all of these because I don't think it's a great use of your time for the exam. So in closing, I'll just talk to this one that I brought up previously in error. This is 11-13 from chapter 11. When you take a look at this Monte Carlo simulation is pretty much telling you that there's a 23% chance of you meeting your budgetary target of 2.2 million. And that is pretty low compared to an 85% chance of meeting a $2.45 million budget. So all this is showing you is the chances of you being at 2.2 million is low. This is the expected value, the more sensible budget or prediction for your project. Now, if you want it to be all the way towards absolutely almost certain, it wouldn't be here. As you can see, the likelihood of getting to that point is more towards this zone because there's an 85% chance of you getting it done for that. Consequently, that is more probable. That is what the Monte Carlo tells you. All right. That is what you need to be concerned about. There's another tool, which we call the tornado diagram. It's synonymous with the concept of sensitivity analysis, and this helps to determine which individual project risks or other sources of uncertainty have the most potential impact on project outcomes. Now, again, if you take a look at PMI's PMBOK guide, you can see an example of a tornado diagram. And the idea is that the tornado diagram shows you how sensitive these identified risks are on the project. We can see activity or risk driving project duration. And the longer it is, the more sensitive it is. That is what you need to know for your exam. Going any step further than this, in my mind, could be just a waste of your valuable time. You also do know that right now, the focus is very heavily agile. So I would advise you to spend more time worrying about the agile pieces when that time comes. For now, just understand all of this at a high level, stick to the original definition of what if scenario analysis, understand that from the perspective I showed you. And then when it comes to the Monte Carlo, you got to understand it. It is a model. It's a mathematical model used to predict the probability of different outcomes when the intervention of random values is present. Different values for work package costs, different values for task estimates in terms of schedule and things like that. I hope this has helped you to better grasp the idea of simulation and what if scenario analysis. And of course, when we talk about simulation, we're really talking about Monte Carlo from a PMI perspective. All right. For good measure, one final reference. If you really want to go further on this, I would say you could go to Wikipedia, read up all the stuff they've got there. They usually have great information on those pages. But again, I think the risk reward is so minuscule. The reward you're getting from so much time, for this, it's likely you may not even have that many, if at all, one question. All right. So understand the concept at a high level. You're good for the exam. Move on. Don't sweat it. All right. I hope this helps. You take care.